Hi, today we'll solve this problem of Bernoulli. Says that water inside a tank is flowing outside from a little tiny hole. So we have to recall Bernoulli's equation, and now we have to assume that this pressure and this pressure, since are in contact with air, then they are the same pressure and is equal to 1 atmosphere, so they cancel out. We have to recall the continuity equation because it says that the velocity of up here is barely to zero because the flow is flowing through a tiny hole, so it's barely equal to zero. So also that term in our equation of Bernoulli cancel out. Also the densities cancel out because they are in each term. And now we only have to isolate the velocity and we'll get this. Already given us the height from which the hole is, we'll get that the second velocity is of 17.7 meters per second. Now they are asking us for the diameter of that tiny hole. So we know the rate of flow, they're already given us to us. And we know that the rate of flow equals to the continuity equation. So from here we already have the velocity, and from the area we can get the diameter. So pi times r squared is equal to the area of a hole. So that r times 2 equals the diameter. So we only have to substitute that into our equation. But the rate of flow that they are giving us is in minutes, so we only have to convert the units into seconds. Now we only have to isolate the radius, and we'll get this equation: the rate of flow over pi times the volume, and that to the square root, and then we'll get the radius in meters, but we have to convert that into the diameter, so we have to divide that into 2, and we'll get that in meters, and the problem is asking us for that in millimeters, so we'll get a whole of 1.7 millimeters.